Okay, so today I'm going to be looking at extending on the laws of indices. Now, we have done stuff like a square is equal to a to the 1 times a to the 1. Now, what is this a? All the examples we've used is like a to the m to the n is a to the m times n. But what this a here is equal to, let us say a is equal to x plus y. How do we do that? Or we say a um, is equals to m plus n. So in terms of working expansions, like if a is m plus n and I say a square, what is a square? You have to do m plus n square, and you have to work this out. So we will be looking at some scenarios like that now, right? All right. So if I have, let's say, given that a is equals to m plus n, and you're asked to find what is a square, a square is a multiplied by a, right? This is a to the 1, a to the 1. But now you know that a is equals to m plus n. So you have to do m plus n times m plus n. Now, in terms of working this out, how do we do that? Now, it's going to be m, this m here, times m plus n, everything over here, then plus this n into everything over here, m plus n. So you take the m here and you multiply by everything over here. There's a plus sign here, you put the plus sign, then you take the n and you multiply it by everything over here. So what you get, m by m is m square, m by n is mn, plus n by m is mn, nm and mn are the same, and n by n is n squared. So now you have m squared plus mn, or we can put the square terms first. So m squared plus n squared plus 2mn. So that is if a is equal to m plus n, a squared is equal to this here. Now we can express this in another way. You want to multiply m plus n by m plus n, right? So let's look how we can put it in a little grid. So if you have to multiply m plus n all square, draw a grid. Let this be m, n, m, n. So m by m square. M by n, m, n. N by m, n. N by n, n square. And you just add everything in here. So that gives you m square plus n square plus 2mn. Remember, AB is the same as BA. So mn is the same as nm. So we have, this is 1mn and 1mn. We get 2mn, not mn squared. This is adding them up. So mn plus mn. All right? I'll look at it from a different angle now. Clear this? M plus n all square. This is plus, so we're adding everything here. What about a plus b all square? Again, we can just put it in a grid format. A, B, A, B. Because this here is the same as A plus B times A plus B. This is like A plus B to the 1 times A plus B to the 1. So A by A is A square, A by B is AB, B by A is BA, but it's the same as AB, B by B is B square, and you add everything up here, and you get A square plus B square plus 2AB. So this is the same as A plus B all square. This here, this idea is used a lot to expand like some very complex stuff or to reduce some very complex stuff. Because this A can become a next expression. This B can be a next expression. It can be all in bracket square or cube or to whatever power. And you can utilize the same technique. All right? So, let's look at this good. A plus B all square is the same as A plus B times A plus B. Put it in this format. You can work it out, or you can use the first method that I showed you. Now we move on. Suppose you have A minus B all square now. Now this is the same as A minus B times A minus B, because this is like A minus B to the 1, A minus B to the 1. Again, A minus B, A minus B. A by A square, A by, this is positive A by negative B, so you get a negative AB. Negative A by positive B, again negative AB. Now what this means, you might be saying, oh, it's minus B times A, but this is the same as minus A times B. This is equivalent to this. So now minus B, negative B by negative B is a positive, and B by B is B squared, so positive B squared. So A minus B all square is the same as A squared plus B squared minus 2AB. This is 1, this is 2. You add them up. Minus AB plus minus AB gives you minus 2AB. Alright? So we looked at A plus B all square, and now we looked at A minus B all square. Now, what about this scenario? A plus B. This is deviating a little from indices and looking at the scenario like A plus B times A minus B. What will this be? Now, to work this out, again, we can draw this. Let us say on top here, horizontally, we put the first one, and this is the second. So row by column, let's say this is A, this is B, so this is plus B. This here is A, and this is a minus B from this one here. So we get A squared AB minus B by A is negative AB minus B by plus B. It's negative B squared. So our answer would be here A squared minus B squared and minus AB plus AB gonna cancel out. So A plus B times A minus B gives us A squared minus B squared. So we will look at it. I'll summarize it now here, right? We know A plus B, A minus B is A squared minus B squared. And the method to do it. So we have gone through this. A plus B all square is the same as A squared plus B squared plus 2AB. A minus B all square is equal to A squared plus B squared minus 2AB. And A plus B times A minus B is equals to A squared minus B squared. Now we'll use these ideas for other stuff going forward. So I will stop here.